Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape. Kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities. So keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
Take that giant space knife. Yes, you. It's time to visit the sun and check what's inside. First, you're slicing through the corona, aka the sun's wild hair. It's the sun's super thin atmosphere. But don't let it trick you. It's blazing at 3.5 million degrees Fahrenheit. While cutting through it, you see plasma threads whipping around like solar spaghetti. You reach the photosphere, the sun's skin. It's only about 300 miles thick, but it's super bright and sizzling at 10,000 degrees Fahrenheit. Looks like it's covered in little fiery waffles. They're called granules, and they're each about 600 miles wide. Then comes the convective zone, where hot plasma is floating up in bubbly chunks. Next, the radiative zone. This part's like molasses made of light. It takes 170,000 years for energy to crawl through here. Finally, you start cutting into the core, and instant heat wave. It's like the sun's pressure cooker. Gravity's smashing hydrogen atoms together to make helium, and it's cooking at 27 million degrees Fahrenheit. Now, you're gonna need a smaller knife, since the next candidate, Mercury, is the smallest of the inner planets, only about 3,000 miles wide. When you cut through its thin atmosphere, you see little hydrogen and helium atoms escaping inside tiny invisible balloons popping away into space. Next, the crust. Together with mantle, it's only about 250 miles thick. As our giant knife passes through, you see hard rock flakes falling off, cracking under the pressure. Mercury has a gooey outer metal core. Slice carefully or you'll spill some liquid metal lava. Finally, you hit the inner core. Mercury has a massive metal heart. Around 85% of the whole planet is just iron and metal. It's basically a giant metal meatball. Cut through it and watch molten iron juice oozing out like spicy hot sauce. You're now approaching Venus, the hottest planet out there. We're talking about average temps of 870 degrees Fahrenheit, hot enough to melt lead. You slice through the atmosphere and it's crazy. Thick clouds of sulfuric acid swirling everywhere, and it's mostly carbon dioxide. Like a bad greenhouse on steroids. Pressure there is insane, like being 3,000 feet underwater on Earth. Thick yellowish clouds are puffing around the blade, sizzling like acid rain. Then comes the crust. A thin shell of mostly basalt, just 6 to 18 miles thick. It's like cutting through a crispy rock pizza crust, thin but tough. Cut deeper and you're in the molten rock mantle, about 1,800 miles thick. You can see the rocky magma wiggle and ooze. Finally, you hit the metal core, about 1,900 miles wide. That's like slicing a chunk almost the distance from Chicago to LA. There's a giant iron ball inside, all molten and heavy. Alright, time to cut through Earth. Now you might need a whole chainsaw to deal with this rocky planet. First, your chainsaw bites into the crust. It's thin, only about 1% of Earth's volume. You hear a sharp crack as the brittle rocks snap and crumble. Dust and tiny minerals puff out, and the crust breaks into chunks, like snapping a hard cookie. Next, the blade presses deeper into the mantle. Thick, tough rock that's solid but kinda squishy if you wait long enough. As you slice, the hot rock kind of oozes and bubbles, leaving a warm trail along the blade. Keep going, and you hit the outer core, a huge sea of molten metal. Suddenly, the knife slides through thick, glowing liquid iron and nickel, like cutting through a giant cosmic lava lamp. Finally, you smash into the inner core. Solid metal this time, like a glowing steel marble buried deep inside. The blade scrapes across its dense iron-nickel surface with a harsh grind. It's blindingly bright and insanely hot here, hotter than the surface of the sun, and the pressure would squash any real blade flat. Put the chainsaw aside. For the next planet, you'll need something of a more modest size. You're zooming over to Mars, the last of the rocky inner planets. The knife breaks through Mars's crust. It's thin and solid, made of volcanic basalt rock. As the blade cuts in, fine reddish dust, like cosmic talcum powder, puffs up, drifting everywhere. The crust doesn't crack into big plates like Earth's. It's one big solid shell. Next up, the mantle. Think of it like thick, soft, rocky toothpaste. Not totally solid, but not mushy either. The knife slides through it with some resistance, and you see glowing silicate goo in red and orange shades, swirling around the blade. The mantle is thinner than Earth's, only about 800 to 1,100 miles thick, so you don't have to wait long to get to the juicy middle. Finally, you hit the core, a metal mix of iron, nickel, and sulfur. Mars's core is molten, but it's cooler and more chill than Earth's. In any case, it's easy to cut through, no effort needed. We're coming close to Jupiter, the biggest dude in the solar system. Jupiter is a gas giant, basically a giant balloon filled with crazy stuff. As you cut it, you don't hit solid ground at first. Instead, it's all thick, swirling gas, mostly hydrogen, around 90%, and helium. It must feel like slicing into super thick whipped cream that never ends. As you go deeper, the gas gets so squished that it turns into a thick liquid. The blade pushes through layers of swirling storms and colorful clouds that whirl around. Keep going, and the gas becomes metallic hydrogen. The knife slices through a glowing, electrified liquid that crackles around the blade, like you're cutting through electric jelly. Finally, somewhere way deep inside, you reach the core, which might be a molten hot ball of liquid or a giant rock heavier than 14 Earths. Nobody's totally sure. But if you could slice through it, the core would be hotter than 43,000 degrees Fahrenheit. A regular blade would melt instantly or be crushed from all that pressure. It would be pretty tricky to cut open the next planet, not because it's too hard or rocky, but because there's basically nothing to cut through. In Saturn's outer layer, your knife hits thick, swirling gases, mostly hydrogen and helium, but with some funky extras like methane, ammonia, and water vapor. As you cut, a smoggy orange haze puffs out. That's all the sulfur giving Saturn its groovy look. The atmosphere and surface blend together. No hard ground here. As the blade digs deeper, the gas gets squeezed tighter and tighter. Hydrogen starts turning into thick liquid, and your knife leaves trails through this gooey, glowing layer. Keep going down, and suddenly, the liquid gas turns into metallic hydrogen, shiny and electric, crackling around your blade like a sci-fi lightsaber. Deep inside, you might hit a rocky core, but no guarantees. It might even be liquid rock, glowing and swirling beneath all that gas. Next, we're gonna split open an ice giant, Uranus. Its atmosphere has enough methane to give the planet that cool blue-green glow. As your blade moves, a faint icy mist sprays off. It's like slicing through a cold, foggy cloud. Next, you slice into the ice mantle, which makes up about 80% of the planet. But don't think frozen popsicles. This is a thick, hot, gooey soup of water, ammonia, and methane ice. The blade pushes through this dense, slushy ocean with little bubbles and steam escaping as you go. Then, bam! Blade hits the rocky core, small and dense, half as heavy as Earth. It's cooler than most cores, about 9,000 degrees Fahrenheit, which is still crazy hot. The blade scrapes over solid rock with sparks flying off like cutting metal in a cold workshop. Neptune's also crazy cold, but cutting it feels different. When cut, it whips clouds of frozen methane, flying past at 1,200 miles per hour. It feels like slicing through a freezing, super windy blizzard. Next, you plunge into the mantle, a thick, boiling hot soup of liquid water, methane, and ammonia. The knife pushes through this dense stew with bubbles popping and steam hissing. Temperatures here range from 3,000 to 8,500 degrees Fahrenheit. Even deeper, the blade hits Neptune's solid core, mostly iron, metals, and silicates. The blade scrapes along this tough metal center, sparks flying like you're welding the heart of the planet. Now, comment below, which planet was the most satisfying to cut through?
So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new – planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot, it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors, or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP-18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers modeled how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth. So, what is the habitable zone? Well, in my room, it's the small section which isn't buried in food wrappings and video games. But astronomically speaking, it's a region around a star where the temperature of H2O matters. Too hot and the water will evaporate. Too cold and it will freeze. So just like Goldilocks, the habitable zone is just right to allow liquid water to exist. And water is essential for life as we know it. Just ask the three bears. The size of this zone depends on the temperature of the star, but the habitable zone isn't necessarily a guaranteed oasis of life. Other factors, such as a planet's atmosphere and magnetic field, also play a crucial role in this. Scientists have discovered more than 5,000 planets outside our solar system, and only 63 of them are potentially habitable for life forms like on Earth. Kind of a cosmic lottery. The good news is, this rule also works for the moons. If moons of planets are within the habitable zone, they may also have conditions suitable for life. That would be a jackpot in our lottery, 2 oases for the price of 1. In our solar system, this zone is within a range of 80 to 111 million miles. Of all the planets, only we were lucky enough to have life. But what if we could make all the planets in our solar system habitable? Well, let's start with Mercury. First off, we'd need to give Mercury a bit of a makeover by thickening its atmosphere and providing it with a magnetic field. So let's shower it with some asteroids that contain water. It's terraforming time, baby! Mercury is the closest planet to the Sun, which means it gets plenty of sunshine. So, not that it needs any help in that department. Actually, Mercury needs to chill out a bit. Right now, it's 800 degrees Fahrenheit. That's too hot, said Papa Bear. That's why we should move it to a more habitable orbit, about twice as far away from the Sun as it is now. Now, thanks to terraforming and pleasant temperatures, we'd finally get some water. And if we want to get really cozy, we could always build habitats underground or on the surface, but then we'd have to shield them from the heat and radiation. Anyway, with a little creativity, we could make it work. I mean, people live in Arizona, right? Yeah, but then we'd need a lot of golf courses. Let's move on to Venus. The famous planet of love, where the temperatures are hot enough to melt lead and the atmospheric pressure can crush you in seconds. Isn't it romantic? Venus is referred to as Earth's sister planet, but as it often happens with siblings, we have almost nothing in common. Well, let's try to solve this problem. If we add some hydrogen on Venus, it could react with the carbon dioxide in the atmosphere to form water and graphite. Water would help us to create some oxygen, but for this plan to work, we'd need to get hydrogen from space like it's a Black Friday sale. After that, we can build our new homes. We'll just have to make sure the buildings are strong enough to withstand the winds and acid rain. Piece of cake, right? Luckily, with the next planet, things are much easier. Mars is often considered the most promising candidate for extraterrestrial life in our solar system. It's a rocky planet with a thin atmosphere, but it has signs of water on its surface. And not only water, but even microbial life. So, the Martians must think of us as extraterrestrials. Anyway, if we're going to terraform Mars, adding oceans is a must. They'd thicken the atmosphere and warm the surface. Time for another asteroid shower. Or we could create some giant mirrors to reflect the sunlight and melt the ice caps. Easy peasy. And as soon as oceans appear on Mars, it'll gradually turn into a lush green planet, very similar to our Earth. After that, we'll just need to build some artificial habitats and make sure they have all the comforts of home. Now, making rocky planets habitable isn't that difficult compared to the gas giants. Jupiter has no solid surface at all, and it's basically impossible to colonize. So let's get creative. We could build floating habitats in the clouds of Jupiter, where temperatures and pressures are more Earth-like. We just need to protect them from little inconveniences, like wind speeds of more than 400 miles per hour and lightning every other minute. But if we manage to build homes in Jupiter's atmosphere, we could have some truly unique views. Just imagine waking up every day and seeing swirling clouds and colorful bands out your window, or taking a stroll through the gas giant's thick atmosphere. Scary and awesome. Just watch your step on that balcony. We could also use some high technologies to make Jupiter's atmosphere breathable, something that would consume its gases and release oxygen. Now, this is pure sci-fi, but wouldn't that be cool? Let's move on to Saturn. It's also a gas giant which has no solid surface for life to exist. But don't lose hope. Just like with Jupiter, we could create some floating habitats in the upper atmosphere of Saturn. Try living on a luxurious cloud, although the rent would be sky high. We could also cover the planet with a giant shield, like a cosmic umbrella. In space, it's raining cosmic rays instead of water. But this barrier could protect us from harmful radiation and solar winds. Thanks to this, the weather on Saturn would become a bit calmer. Also, remember how we were talking about moons? One of Saturn's moons, Titan, has a dense atmosphere and maybe even a subsurface ocean of water. Enceladus also hides an ocean beneath its crust. Both of them might be perfect places for actual colonization. That would be much easier than colonizing Saturn. Uranus is another ice giant made up of dense fluid icy materials, methane, ammonia, and water. Considering the surface temperature of minus 353 degrees Fahrenheit, you could say it's pretty chilly out there. So how do we make this work? Well, we could try to create a greenhouse effect. It's a natural process that helps keep the Earth's temperature stable and pleasant, unless we mess around with it. When sunlight enters the Earth's atmosphere, some of it gets trapped by gases called greenhouse gases. They act like a blanket around the Earth, keeping the planet warm, unless we mess around with it. So, if we want to make this ice giant warmer, we can try to recreate this effect, only better. For example, we could introduce some of these gases into Uranus's atmosphere, or build a network of mirrors to trap the heat from the sun. Although it would require tons of giant mirrors, and just imagine trying to position them all correctly. So, instead of all this headache, we could always set our sights on Uranus's moons. They're believed to have rocky surfaces and maybe even oceans that could support life. Plus, the views are out of this world. Moving on to the final planet, Neptune, the cool, distant cousin of the solar system. It's also an ice giant. Its year lasts 165 Earth years. Now first, let's create an atmosphere. Neptune's atmosphere is mostly made up of hydrogen, helium, and methane. Phew. We need to transport some plants there, or simply lots of oxygen to make this place a bit more breathable. And how do we add water to a gas giant? Maybe by melting ice from the moons, or by transporting large amounts of water from Earth. Just imagine a squadron of spaceships dragging giant containers to Neptune. And then, once the planet has a breathable atmosphere and liquid water, we'd need to build habitats. Probably another sky city, because you can never have enough of those. So let's say we somehow magically made all the planets habitable. Now what? Well, there would be a boost in human exploration and colonization. People would build new homes on different planets. Imagine immigrating from Mercury to Neptune because you prefer chilly temperatures more. With more habitable planets to study and explore, scientists would learn more about our world. We'd have so many breakthroughs. Also, it's time for some interplanetary trade. We could mine tons of resources from planets, asteroids, and moons. A dream come true for Elon Musk. But of course, it's not all fun and games. All of this would most likely lead to conflicts over resources and territory. Imagine trying to keep peace between Jupiterians and Martians. Well, all jokes aside, The possibility of all planets being habitable is mind-boggling. But in reality, terraforming planets like this is impossible, at least for now. But who knows? Many things were considered impossible before, but this didn't stop us. So, let's keep dreaming. Meanwhile, we can clean up the planet we're already on.
Jupiter's moon Europa is covered in a thick layer of ice, but underneath it is a vast ocean of water, measuring up to 100 miles deep. Water ice was previously thought to be rare and only common on Earth. But it can, in fact, be found all over the solar system, even on Mercury and the Moon. Saturn is less dense than water, so if it were thrown into a giant pool, it would float. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? You don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. There are 8 confirmed planets in the solar system, but evidence shows there can be a 9th, we just haven't discovered it yet. Organic matter could have been brought to Earth by comets, since it has been found on several of them. Saturn also has a never-ending storm, just like Jupiter, but it's also peculiar for its shape. It has 6 distinct sides. Mercury and Venus are the only planets in the solar system that have no known moons. Jupiter has 79 known moons orbiting it, the largest of which is Ganymede, and it's bigger than Mercury. It was thought that the Milky Way was a belt before, but now we know it's a spiral galaxy. Footprints on the moon can't disappear because there's no wind to blow them off the surface. There's a theoretical possibility of a white hole, the reverse of a black hole. Nothing can enter it from outside, but light and matter can escape from within it. Although there are trillions of stars in space, we can only see a tiny fraction of them in the sky. Charon, Pluto's moon, is half the size of its planet, which is why Pluto orbits a bit around a spot outside its own axis. All the objects in space, including planets, interstellar dust, and whole galaxies, comprise just about 4% of the universe. The rest is dark matter and dark energy that can't be seen and isn't fully understood. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants, similar to Jupiter and Saturn, but the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189733b, I won't say that again, is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. Plus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Kepler 70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler 70b, and it still exists. But the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our sun. It was lucky to survive spending time inside the star, but it's evaporating now, and will probably be no more in the near future. If the sun was the size of a front door, our planet would be the size of a nickel. In other words, the sun could fit more than 1 million Earths. Moon rocks have a super slow erosion rate. That's why the Apollo astronauts' footprints left on the moon are likely to stay there for 10 to 100 million years. Another one of Saturn's moons, Iapetus, has unique two-tone coloring. The difference between the satellite's two hemispheres is impressive. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery just yet. All the planets of the solar system would fit between Earth and the Moon with some space left. Yes, there's lots of space in space. Saturn isn't the only planet that has rings. Gas giants Uranus, Neptune, and Jupiter have rings of their own, but they're thin and almost impossible to see. NASA can convert plasma waves, radio waves, and magnetic fields into audio tracks and listen to what's happening in space. They record all kinds of intriguing sounds, from beeps to ambulance-like howls. At the same time, space itself is an eerily silent place. There are some sound waves and vibrations, but people can't perceive them. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish-red sky turns blue as the sun goes down under the horizon. It's because Mars is much further away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique system of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles, so, depending on where you are, sound waves can be possible. Discovered in 2017, Kelt 9b is the hottest planet we know of. That's because Kelt 9b orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? You wouldn't? Okay. One moon day is equal to about 29 days on Earth. It takes that long for the sun to cross the lunar sky. People always see the same side of the moon. The Earth's gravitational field makes the moon spin around its axis slower. That's why it takes the moon the same time to rotate around its axis as to orbit around the Earth. It was only in 1959 that people could finally see the other side of the moon, thanks to a photo taken by the Russian spacecraft Luna 3. The other side of the moon is more mountainous than the one we see from Earth. It can be explained by the Earth's gravity, which made the crust on the visible side of the moon thinner. Craters on the moon were left by asteroids 4.1 to 3.8 billion years ago. They're still visible, only because geological changes on the moon aren't as active as on Earth. The moon's gravity is only 1/6 of that of Earth's. You would be able to walk a distance 6 times longer and carry a weight 6 times heavier there. Though it's easier to walk, it's more dangerous too. An astronaut's foot in a heavy spacesuit might sink into the moon's ground. Long-distance jumps can be uncontrolled and dangerous, as the moon's surface is full of deep craters. Because of the low gravity, lunar dust consisting of tiny hard and very sharp particles and smelling of gunpowder is all over the moon. It makes a mess, causes symptoms like hay fever, and gets into spacesuits, ruining them. It's not all bad though, since at sunset and sunrise, the dust sort of dances. It floats above the moon's surface because electromagnetic forces make the particles float up. The moon does have a kind of atmosphere which is called an exosphere. It consists of helium, neon, and argon. It's 10 trillion times less dense than on Earth.